All right, so now it is finally time to do a mass stoichiometry example problem. The problem on your screen is what we're going to do. You do not need to draw the oxygens and the hydrogens here. This is just an excerpt from the periodic table, just so I can refer to that instead of having to pull up the periodic table. But the balanced equation is here in blue, and then the problem is down here at the bottom. We're going to work through this together. So make sure you write down especially the balanced equation and the problem down here at the bottom up. You can pause here so that you can do that. All right, so how do we do this kind of problem? Well, it's just like those problems that we had on Friday. I'm gonna move things around just a little bit here. Just like those problems that we had on Friday, except now what we've got to do is we've got to draw a line like that. Oh, you know what? I skipped the first step, didn't I? There's a fly buzzing around in here. Sorry. The first step, right? What's the first step got to be? The first step's got to be to balance that equation. So let's go up here and balance this equation. This is the same one that we had on Friday, so it's pretty easy for me to balance in just one quick step there. So that's always the first step. The second step is figure out where you're going to start. And where are we going to start? We're going to start right here, 3.0 grams of oxygen gas. So I'm going to put the 3.0, that's easy enough, that's the number. The grams, shortcut of G, oxygen gas. Which of these things is oxygen gas? Well, O2, right? It's the only thing with oxygen just in it. That's the first step. The second step is we're going to go out to the end. What does it ask me to find? How many moles of water? So we're going to go to moles. I got to figure out which thing is water if I didn't know. Luckily, hopefully we all know this one. This is moles of H2O, because the description says hydrogen gas reacts with oxygen gas to produce water. So the only thing produced is water, H2O. All right, great. So now we've got to go from moles of H2O. All right, before we always started with moles of O2s. This doesn't have moles of O2, it's got grams of O2. So the first thing I need to do here is make this look like a problem from Friday. So I've got to get rid of that grams. I'm going to put grams of O2 down here on the bottom, and I'm going to put moles of O2 on the top. You can always go from grams to moles in a step, and the way you do that is using the molar mass of this thing right here. That thing right there, the molar mass of that is that 1 mole of O2 is equal to, we look up on the periodic table, and I'm going to scroll back up just a little bit here so we can see this. We look up on the periodic table and we realize an oxygen is 16.00 grams per mole. Since it's O2, we're going to take that and multiply it by 2. 2 times 16.00. And that's going to give me grams of O2. That is 32.00 grams of O2 because I plugged that into my calculator, this calculator right up here, and that is our molar mass. So 1 mole of O2, and what we wrote up here is what we're going to translate into down here in the step. It says a 1 in front of moles of O2, so we're going to put a 1 there. And it says 32.00 grams of O2, so we're going to put a 32.00 grams of O2 right there. Check. Scroll down now. That step is over, so we're going to see what we cancel out. Gone. Gone. Grams of O2 is on the top and on the bottom, so it cancels out, right? There's a grams up top, grams of O2, excuse me, grams of O2 on the bottom. Now we've got moles of O2, and that's what we used on Friday, right? So once you're to moles, then you can do, we're going to put O2 down here on the bottom, and we're going to put H2O up on the top because we'd like to go to those. Some folks even go so far as to put like moles in here. I don't like to do that, and the reason I don't like to do that is because it's really easy for me to look up in the balanced equation and realize there's a 2 H2O right there, and there's a 1 in front of that O2 in the balanced equation. Remember, these came from the balanced equation, right? That's where we got this step from. We can even draw a circle around that. Show the arrow pointing up to that to show that these came from that balanced equation right up there. Now what cancels out? Well, O2, gone, gone. And the only thing we're left with is moles of H2O. And that's what we want. We want moles of H2O. Check. All right. Plug this into your calculator. You do 3.0 times, I'll put a multiplication symbol in there, sorry, times 1, I'm not going to plug that into my calculator, times 2, actually, wait, I forgot something. Some of you might be yelling at me right now. saying, hey, wait a minute, there's a 1 on the bottom, gone, and a 1 on the top, gone. So so fudge this. We're not going to, there we go. Let's start that back over there. We got 3.0, not times 1 because we canceled it out, but times 2 because there's a 2 on the top, divided by 32.00, and a lot of people then go times 1. We already canceled that, but if it was still there, we go divide by 1 because that 1 is on the bottom. Don't forget, multiply each thing on the top, divide by each thing on the bottom. All right? So 3.0 times 2 is 6, 6 divided by 32. Oh, goodness. You don't have to do this in your head, by the way. You can use your trusty, dusty calculator. Right now mine's coming out in scientific notation. I don't want that. I'd rather have this in non-scientific notation. So we're going to round that to 2 decimal places, 0.19 moles of H2O. The calculator actually said 0.1875. I'm going to round to the second decimal place. Since the next number is higher than 5, rounds up to a 9. Check. You've been doing that since like the 5th grade or so, right? But it's a good reminder. Always good to have a reminder in there, right? 0.19 moles of H2O is what we get for this. And that's how you do a mass stoichiometry problem.